In this lecture, we'll look at data visualization using Matplotlib. As you know, Matplotlib is a package used for data visualization. Here is the official link for Matplotlib. If you go to matplotlib.org, you can find out and read more about Matplotlib. We'll look at some examples, but you can explore more of the features here. This is the home page. If you look at examples, you'll see a list of various examples. And here, if you click on gallery, you'll see lots of figures that are drawn using Matplotlib. And if you click on any specific figure, you'll see the associated code. Okay, you can read more about any of the figures you are interested in. Okay, without further ado, let's start our discussion on Matplotlib. So the first thing we need to do is import our package, and let's also import NumPy and Pandas. So import Pandas as PD, import NumPy as NP, and let's also import Matplotlib. So we'll import Matplotlib's pyplot as PLT, and let's also use our Matplotlib inline magic function so that we can see our graphs on Jupyter Notebook. Matplotlib inline. Let's draw a simple graph using Matplotlib. What we'll do is we'll define our x and y values and then use those values to draw our graph. So for our x-axis values, I'll use NumPy's line space method to define some points to use. So np that we'll call the line space method, line space, and then let's see. We can use points from -6 to 6, and then let's use 200 points maybe. Okay, that's for our x-axis. And for our y-axis, let's draw a graph of cosine function. So we'll store it in a variable called cos for cosine, and NumPy has a cosine function, so we'll call NumPy's cosine function and then pass the x variable we defined earlier. So this will calculate the cosine value of each of these points defined here. Okay, so we'll use this as our x variable and this cosine as our y variable. So the next thing we need to do is this Matplotlib has a function known as plot, and that will help us display the graph. So plt that we'll call the plot function and then pass our x and y variables. So x, and our y value will be this cosine. Okay, now if we run it, we see a simple cosine graph, a graph consisting of our x values, x-axis, and y-axis. So here is a simple cosine graph. Now let's do the same thing and draw another graph, and for this graph we'll use the sine function. So I'll copy the values for x, and for our y I'll save it in a variable called sine, and we'll use NumPy's sine function to calculate the sine of each of these values in our line space method. And then we'll simply call Matplotlib's plot function and then pass our x-axis and our y value, which is sine in this case. So if we run this, we get a sine function. Okay, our x-axis and y-axis. So this is a simple sine function. Okay, and what I'll do next is display both of this cosine and sine functions in the same graph. How can we do that? So it's simple. Let me copy our value for the x-axis, and in the same set we'll define our y value, which is cosine and sine functions, so we'll define them separately. So we said np dot cosine of x. Let's also use the sine function, np dot sine of x. Next, what we can do is call Matplotlib's plot function and pass x and cosine. That will be for our first figure, and for our second figure we'll pass x and sine of x. So if we pass or call the plot function within the same cell, both of the graphs will be displayed as one. So let me run it and show you. So now we have sine of x and cosine of x in the same graph, right? In the same figure. Okay, we know that the blue one is cosine of x and the green one is sine of x. So we haven't defined any colors to specify which function is what, but Matplotlib did that for us. Since those are two different graphs, it used blue for one and then green for the other, right? So what we'll see in the next lecture is how we can modify some of these characters, how we can specify a specific color to one of our plots and a different color for the other plot, how we can adjust our x and y values and so on. Great. Thank you everyone, and see you at the next lecture. Hello everyone and welcome. In this lecture we'll look at how we can change default properties for our Matplotlib's graphs. Okay, if you haven't, let's start by importing NumPy and Pandas and Matplotlib's pyplot as PLT, and we have our Matplotlib inline special function. So what we'll do is use our previous graphs, the sine and cosine function, and see how we can change some of the default properties. Okay, so in the previous lecture we defined our x and y axis, and we used those points for our graphs. So we used np's line space method, and we used points from -6 to up to 6, and we consider 200 points. You can change these values if you want, it doesn't matter. Okay, and for our y-axis we use the cosine function for one of our graphs, and we use NumPy sine function for the other. So np dot cosine of x, and for sine we used NumPy's sine function, right? And we were able to display the graphs by calling Matplotlib's plot method and then passing our x and y axis, and plt.plot x and then sine of x. So if we run this, we get sine and cosine of x on the same figure. So one thing we can do is, so this is the default size of our figure, and there is a function that we can call known as the figure function, and then we can pass an attribute known as fig size, and we can adjust the size of the figure depending on our notebook. So let's call that function. So here what I will do is I'll call the figure function, so plt.figure, and then pass the figure size attribute, fig size, and then set it to whatever size fits your notebook well. Let's try 10 by 5 maybe. So let me run the cell again. Okay, it looks nice. So you can adjust it depending on the best fit. Okay, you can change these values. For instance, if I copy this whole thing, paste it here, and let's make it 10 by 7. So you see the difference? This looks like a little bit better fit. So you can adjust it to what fits your notebook the best. Okay, now let's see how we can change some of these default values. For instance, here we have our cosine function, right? Our cosine graph. The blue one is cosine. So in order to make sure that that's the cosine, we can pass some other attributes to our plot function. For instance, we can adjust the color. We can set the color to be equal to, let's say, red maybe. Okay, that's one thing we can do. Another thing we can do is we can adjust the line width by passing an attribute known as line width, and we can set it to a value that we like, let's say 2.0. Okay, let me run this and show you the difference. So if we run this, now we know the cosine plot is in red and the line width is 2.0. You see, it's much thicker than the one in blue, or the sine function. Similarly, we can pass some attributes to our sine plot. Let's use a color of green maybe, and let's also pass a line width attribute. So line width, and let's set it to be 3.0 maybe. Run it. Line width, oh, spelling is not right. Let's run it again. There you go. The green one is for our sine plot, and the line width is 3.0, so it's much thicker than the red one. Another thing we can do is adjust this ticks on our x and y axis. For instance, here on the x axis, the ticks go from -6 to 6 in step sizes of 2, right? So -4 and then -2, 0, 2, and 4. What we can do is we can pass a function known as x ticks and then adjust the ticks the way we want it. Okay, let's see how we can do that. So I'll copy this, paste it here, and then I'll call the xticks method. Okay, so we have from Matplotlib, we'll call the xticks method, and let's use NumPy's line space method. And then, so let's say we want 12 ticks from -6 to 6, and then we want, let's say, 12 ticks. So if we run this, so now you'll see 12 ticks from -6 to 6. Okay, that's how we can adjust our x ticks, and we can do the same for our y ticks. So here by default we have, for our y tick, we from -1 to 1, we have 3 ticks in step sizes of 0.5. We can change that default by calling the yticks method, and then let's use the same NumPy's line space method, and then so let's use from -1 to 1, we want, let's say, 6 ticks. Okay, run it. So now you see 6 ticks, 1, 2, 3, 4, 5, 6, and the step size is now the step size is now 0.4. Right? Earlier it was 0.5. Another thing we can do is adjust our x limits and y limits for our figures. And we do that by calling the xlim and ylim function. Let's say an example. So plt.xlimit, let's say we want to use points from -3 to 3. Okay, if I run this now, you'll see it's from -3 up to 3. It's no longer from -6 up to 6. Okay, we can do that, and similarly you can adjust the y limit by calling the ylim function, and let's use -0.8 to 0.8. And if you run it, you will see a graph that looks like this. One example I want to show you, let me make it from -1.8 to 1.8. And if I run this, you see a nice oscillation. And furthermore, you can change this x limit values to, let's say, -8 to 8. So if you run this now, you'll see the graph stops at -6, right? You see it's between -6 and 6. That's because when we defined our graph, here we specified our x-axis to be from -6 up to 6. So it won't be outside of this range. However, the margins of our graph goes beyond those points. That's why you see the difference here. Okay, so that's how we can use the x limit and y limit, xlim and ylim, to adjust some of the default behaviors for our graph, for our figures. Okay, so try out some of those and see what you can get. Great, thank you.